Okay.
It is visible, sir.
Okay. Thank you, sir. Okay. Hope this is visible to you all.
Yes, sir.
Okay. So let me start formally. Respected Swanirbar sir, head of the Department of IT, Tripura University. My organizers like Jan sir, and respected all the teachers who have participated here. So at the outset, I would like to convey my sincere and heartfelt thanks to the Swanirbar sir and the organizers who have given me this opportunity to share my experience. And mainly, I will be talking on practically devising algorithm. So once again, I would like to welcome the teacher participants, my dear and respected teachers who are the like building block of this nation. So I welcome you all and I thank for your valuable time that you have given for hearing me. So I will be talking on practically devising algorithm in this 5 days online program on embedding computational thinking to make education systems relevant for the youth. This is the outline of my presentation. First, we will see why there is a need to bring computational thinking to the schools. And then mainly we will be concentrating on the algorithms, like what are the algorithms, what is its purpose, and the key concepts associated with the algorithms. And then we will see the characteristics of the algorithm, that what makes our algorithm very good and robust. And then as this program is organized for our beloved teachers, so we will be also referring to CS Sala. Okay, and from there we will take some examples and we will learn that how this will be much beneficial to our school students, starting from class 1 to class 12. And at the end, I will summarize by giving the important references from where I have collected the materials to share my views. When we talk of computational thinking, so we all know that uh, as we participate in this digital revolution, we need to train our children on skills for the digital age. These days, we can see that everything has become digital. And in this pandemic, we find that even the schools are closed, but because of this digital support, digital revolution, we are able to continue our education through online. So here we see how our children are skilled, how they have been giving. We are able to impart education for them. So basically, when we say computational thinking, so it has been recognized as one of the key 31st century skill, and it involves understanding a problem, designing a solution, and expressing it in a form that a human or machine can execute. In fact, this computational thinking has been introduced into the mainstream curriculum in many of the different countries, and India has joined this. Even the National Education Policy 2020 recommends that mathematical and computational thinking will be given increased emphasis through a variety of innovative methods, including the regular use of puzzles and games that makes mathematical thinking more enjoyable and engaging. In fact, we know our Indian education system. When we go to just have a glimpse of our history, we find that our education system was very strong. But later on, like when we see Nalanda University, so that was the topmost university. But later on, when history teaches us that how the education system of India has declined, and later on, like European and US these countries, they have dominated, and then they set up MIT, Stanford, and they have they saw that how in the world ranking their universities comes on the top. So there was a need to have again to regain our education system which we lost. That's why like many changes have been adopted and recommended it, and out of which our national education policy 2020, this also recommends that mathematical and computational thinking should be given emphasis for our school children for our education in order to strengthen our education system. And in this context, CS Patsala, which is an association for computing machinery India, short we say ACM India, it has an initiative to bring a modern computing curriculum to Indian schools. And when we talk of computational thinking, so computational thinking is a problem solving process that includes a number of characteristics and dispositions. Computational thinking is essential to the development of computer applications, but it can also be used to support problem solving across all disciplines, including the humanities, maths, and science. Students who learn computational thinking across the curriculum can begin to see a relationship between academic subjects as well as between life inside and outside of the class. Uh, and there are four keys that will help us to think computationally through a complex problem or a challenge or a task before writing a single code or before solving the problem using computers. So these four keys for the computational thinking are mainly decomposition, abstraction, pattern recognition, and at the end, algorithm design. And here in this talk, in this discussion, we will be more focused on algorithm design. So there are four principles of computational thinking. Rather, we say that the computational thinking has four different components. So the first is decomposition. Decomposition, basically, this is the breaking down a complex problem or a system into smaller, more easily solved parts. So a big problem is decomposed into a smaller and easily solved problems or parts. And these smaller problems are solved one after another until the bigger complex problem is solved. So basically, it's a breaking down data, processes, or problems into smaller and manageable parts. And then after that, it comes abstraction. So abstraction, it refers to identifying the general principles that generate these patterns. And then this pattern recognition. So pattern recognition, basically it's the observing patterns, trends, and regularities in data. For example, like sometime like if suppose if we have put a key in our pocket, so no need to check the key, no need to just pick out the key from our pocket and we have to visually see it, not required. Just we put our hand and by pattern we can understand, okay, this is the key of my vehicle or this is the key of my home. So pattern recognition has a big importance in the computational thinking. So and in this world, like everything has some pattern, whatever we consider, like clouds, and based on this there is a chaotic theory, and it goes very deep. So basically pattern recognition, it observes the patterns, trends, and regularities in the data. And at the end, in our computational thinking, we design algorithm. So algorithm design, basically it refers to developing the step by step instruction for solving the problem. So algorithm design means we develop step-by-step procedure or instructions to solve a particular problem. So that is the algorithm design. So we will be more focusing on the algorithm design. But as we discussed about computational thinking, let me just share a very small video with our participants. So we will go to the Google, and then in the Google, we can type CS Patsala. Okay, CS Patsala. So we will be discussing about CS Patsala also. So here, like when we scroll it down, here we have a video which says about the computational thinking. So we will be seeing about what exactly computational thinking means. Okay, so let us see this video.
How do you map the entire human DNA sequence? Is it really possible that William Shakespeare wrote all of the works that bear his name? Can you create an intelligent computer program that can write its own novel music compositions? What do these three real-life questions have in common? Well, answering these questions requires the use of computational thinking, which is a way of thinking that more and more people are using to solve problems each day. So whether you teach math, science, computing, or the humanities, computational thinking can be a powerful addition to your classroom activities. So what is computational thinking?
Computational thinking is an approach to problem solving. So it's taking apart a problem and figuring out how to attack it using what we know about computation. There's four major sort of facets of computational thinking. One is decomposition, breaking something down and figuring out what all the parts are and how you might divide up a task.
And then there's pattern recognition, which is finding similarities and differences between these parts in order to make predictions. Pattern generalization, or abstraction, which is finding the general principles that generate these patterns. And finally, there's algorithm design, which is developing the step-by-step instructions that solve similar problems. People are learning to apply computational thinking to solve problems in many disciplines. When people ask difficult questions, which are more easily solved by computers, or discover insights through analysis of large data sets, they are thinking computationally. Computational thinking is the reason we now have fields like computational biology, computational chemistry. It's also the reason we have new techniques we can use in literature, social studies, and the arts.
So when we start stepping back and looking around us, we see computational thinking everywhere. And it doesn't have to be a scary thing.
Some people confuse computational thinking and computer science, but they're quite distinct. Computer science is an academic discipline involving the study of computation and its application using computers.
Whereas computational thinking is a way we go about attacking problems.
Right, using big picture processes and abstract ways of thinking.
It's something that you could use regardless of whether or not you're a computer scientist or something else. It's a general skill that would benefit you.
Computational thinking increases students' confidence in dealing with ambiguous, complex, or open-ended problems. We believe that all students should learn computational thinking, regardless of subject or age group.
Being able to take a problem, break it down into many different sized pieces, work on each one individually, and eventually bring it all together to solve something, that's a skill that can benefit anyone.
Imagine that you're a journalist and that you want to know what people are saying about an upcoming election. One option is to ask people on the streets about their opinion. Another option is to use a computer program that can analyze social media posts on thousands of web pages in just a few seconds. See, this is an example of the benefit of approaching a problem computationally. So, in the past, if students wanted to see and understand data, they needed to collect the data manually. Now, by developing an algorithm, students benefit from quick results and are able to focus their attention on insights rather than data collection or calculation. By leveraging the strengths of technology, we can focus on our strengths as people, developing insights, analyzing situations, and drawing conclusions. We don't want students to simply use the models that we teach. We want students to be able to create their own models. And to do so, students must find the hidden patterns and insights that can be discovered with computational thinking. Computational thinking is not an additional burden or an extra topic that needs to be taught. Rather, it's an enhancement to your existing curriculum.
So with my students, early on, I just try to use everyday examples to help them understand that it's something that's accessible to them. And then they can start to see how computational thinking does exist in other aspects of their life.
If our students are technology creators, armed with computational skills, they will not only be able to participate and position themselves professionally in a global society, they'll also be able to contribute to society by solving big problems using creativity. So how did we map the human genome? Well, algorithms and computer programs helped us to sequence the millions of base pairs in our DNA. And what about Shakespeare? Turns out computational analyses of the vocabulary, themes, and styles in Shakespeare's works confirmed that he could have indeed written all of the works attributed to him. And that intelligent music-composing computer program? Well, computational thinking was used to find patterns in existing musical compositions and write programs that produced brand new compositions based on those patterns. All of the remaining grand global challenges facing us as humans are problems that require an interdisciplinary approach. By integrating computational thinking skills in all of our subjects, we're preparing students to contribute new solutions to seemingly impossible problems. So yes, many mysteries still remain. For example, what causes gravity? Can we create cures for diseases like cancer? We may not be able to answer these questions today, but perhaps with computational thinking skills, our students will be able to answer these questions in the future.
So I hope that this video was interesting to all of my dear teachers. So this video was mainly to give a brief idea about the computational thinking. So it was very nicely compiled, and it tells that basically this computational thinking is to break down a complex problem in order to solve a bigger problem, and by breaking down into a smaller and manageable problems. And then it has key components of decomposition, abstraction, pattern recognition, and algorithm design. And there is often we have some confusion about computational thinking and computer science. So there is a difference between computational thinking, the way we think, the human being, or the way we think to solve a complex problem without using a computer, is a computational thinking. It's a thinking. Whereas the computer science, basically it uses computers and electronic medias or electronic devices to solve a particular problem. So we should always be clear about what is a computational thinking and how it differs from the computer science. So I have compiled some of the major differences between these two. So computational thinking, as we have seen from the video and also we discussed, that it breaks a complex problem into a smaller parts or steps which can be we used to manage, which will be a manageable problem. Whereas in computer science application, it breaks a computational graph problem into suitable sections, and each one will be completed by a different computer processors. Okay, but in computational thinking, we do not require any computer. Similarly, like this computational thinking, it recognizes and tries to find out the patterns or trends in the data or in the problem. Whereas in computer science application, it visualizes data, comparing microchip material and computer speed to notice a trend or change in the data or in the problem. Then this computer thinking, it develops instructions to solve a problem or steps for a task, which is more commonly known as algorithm. So in computational thinking, it develops some instructions to solve a problem step by step. Whereas in computer science application, we write a computer program to sort out the data. Computational thinking, it generalizes patterns and trends into rules, principles, or insights. Whereas in case of computer science application, it realizes complex data structures which requires less code than complex programming. So it realizes complex data structures require less code than complex programming. So this is the basic difference between computational thinking and to that of the computer science. Now we will be coming to our algorithms, because mainly this session has been designed to discuss on the algorithm. So here we are going to discuss about what exactly algorithm is, what are the characteristics of algorithms, what things makes the algorithm a better one, or what are the characteristics of a good algorithm. So here we will be discussing these things. So in the Google, I just before preparing this talk, I just typed in the Google that algorithms in our daily life. So you also can type this in Google as per your convenient time. So when I typed this algorithms in our daily life in the search button of Google website, I found around 7 crore 58 lakhs results within 0.6 seconds. And it shows that how well these algorithms are well developed or a mature words, and what the popularity it has. So, and we can use these algorithms, and out of this search, I concluded that we can use algorithms to describe ordinary activities in our everyday life. For example, we can consider a recipe as an complex algorithm for cooking a particular food. Okay, so we can use algorithms to describe many activities of our daily life. So now the question is, what is an algorithm? So algorithm, we know that it's a part of the computational thinking, as we discussed earlier, but here we say that when we see the formal definition of algorithm, then an algorithm is a sequence of steps to perform a task given an initial situation. So it's a step-by-step procedure to solve any particular problem. So this is the algorithm. Okay, so once again, as I know that here, like, participants are the teachers, so they all know how to teach the students well. They have been teaching the students very well, and it becomes very difficult to teach the kids to the children as compared to a very matured person. So I have with very due respect to the teachers, as they have been devoting their time in teaching the kids. They know well. So here just we will be discussing, like, in context, that how what these algorithms are, and exactly how this can be imparted well to our students. So when we say what is an algorithm, so basically it's a sequence of steps to perform a task. And these examples I have given the courtesy of my reference to. So here, like, we have lots of examples of algorithms which we encountered in our daily life. So here I have collected some of the examples, like when we say a recipe, when we want to cook some food. So this recipe can be considered as a very high level example of algorithm, high level algorithm example, a recipe. Because when we try to prepare some recipe, we must follow some steps, and these steps should be in sequence to in order to prepare a very good recipe. Okay, so a recipe is a high level algorithm. So here in the 1983, this is one example I have taken from my reference to. So here actually it is mentioned that Midlothian oat cakes from Scottish Fair by Norma and Gordon Latimer. They presented in this article in 1983. So we can understand how developed these algorithms are. So actually, first they uh, have shown what are the requirements, like half cup of oat, 1 cup of oatmeal, and so on. So these are the basically steps, like place flour, oatmeal, baking powder, and salt in a bowl. So first we have to take a ball and we have to put all these materials, melt the butter, make a well in the center of the flour mixture and add the melted butter. Roll out dough and cut into rounds. Bake in a warm oven, 300 Fahrenheit for 30 minutes. So what we find that this example is in support with our algorithm. In the algorithm definition, we saw the definition of algorithm as algorithm. Basically, algorithm refers to step-by-step instruction or step-by-step procedure in order to solve a problem. And in daily life, we encounter thousands of algorithms. Here, one example we have taken that a recipe is a high level algorithm. Suppose anything like brushing of our tooth. Okay, so what are the steps required for a children? How to prepare for a picnic, or how to cross the road. So these all are the examples of algorithms. Okay. Similarly, like so here all the instructions are given. So these instructions, these are the set of instructions to prepare a recipe. Hence, this is an example of an algorithm. Similarly, like addition and subtraction and other arithmetic operations are also the examples of algorithms, because it follows certain rules, it follows certain instructions. And one thing is clear, that algorithm is not unique. There may be several ways, several different algorithms in order to solve a particular problem. So it's not unique. Okay, so these are the examples. Now, questions may arise that why we are studying this algorithm. So why are algorithms so important? So the algorithms are pervasive. Pervasive means we cannot unwelcome it. Like aging, we cannot stop aging. One day we all have to be old, and one has to die. So similarly, these algorithms are pervasive. Okay. And they organize thought and action. This is a part of computational thinking, which is mainly focused to solve the problem. These algorithms can be made very precise for implementation on computer, smartphones, and other devices. In a variety of programming languages like Python, R, Java, MATLAB, and so on, these algorithms are required for programming the language. As a computer programs, software package, and in mobile applications, like we have lots of mobile applications these days. So without algorithm, it is not possible to implement these packages and these apps in our mobile or in our computer. And a computer program is an implemented algorithm. So whatever the program we consider, for example, a program to reserve our railway ticket, a program to book our flight tickets. So all these programs, these softwares, these applications, these all are based on the algorithm. In fact, these algorithms are the building blocks of any computer programs or software packages or any mobile apps. So without algorithms, it's not possible to go for computational thinking, or to do computation, or to run any app in the computer or in the laptop or in the mobile. That's why these algorithms are very, very important. Next, we move to know what are the characteristics that makes the algorithm a very good one. So now the question is, what makes a good algorithm? Okay, now we are aware that algorithm is a step-by-step instruction to solve a problem. Then we saw that these algorithms are very important. But now let us see that how these algorithms can be made effective, how these algorithms can be made a good one. So there are some parameters like correctness, efficiency, and comprehensibility. So these are the characteristics of the algorithm. So for a good algorithm, the algorithm must perform the task without error. There should not be an error. Then we will say that, okay, this algorithm is accurate. This gives the correct result. So correctness should be very high for the good algorithm. Similarly, like when we talk of efficiency, the algorithm uses as little time or as little space as necessary. Okay, so we will say that if the algorithm uses less time in order to solve the problem, then we will say that, okay, this algorithm is a good one. So if we compare two algorithms, so say or say we have two different softwares for booking a flight ticket. So one, if it books correctly within a short period of time, then we will say that, okay, it's a good one. Similarly, so we talk of efficiency. When we talk of efficiency, so efficiency of an algorithm can be measured by two parameters. First is its speed, and the another is the memory. Okay, so the efficiency, the algorithm uses as little time or as little space as necessary. So then it will be a good algorithm. So a good algorithm uses minimum time and minimum space, minimum memory in the computer. Then it will be a good. But if I compare, say, two algorithms, one algorithm is if it takes much time and it takes lot of space and memory also, it has more computational load and time requirement in order to solve a particular problem, then we will say that this algorithm is not good. It's not better as compared to the one algorithm which performs which performs or which gives the output or which solves the problem with lesser period of time, and also it takes less memory, then this will be a better one. So I mean that algorithm should have the high efficiency. It means that it should take less time and less space as required. But we should remember that there is always a trade-off between time and space. Generally, it is found that those algorithms which are very fast, it takes a bit higher memory. So there is a trade-off. So we have to choose the efficiency as per the requirement, that which parameter is required or which parameter is more important for us, whether it's the time, computational time, or space. So it depends on it depends on application. Suppose if we want to counter attack the hostile enemy, say if our radar has detected some hostile element coming from different country, and it's very dangerous. In that case, we must in that case the algorithm used must require it must be high efficiencies, in terms of that it must take little time in order to solve that problem. So it depends on the application. Similarly, like one of the characteristics of a good algorithm is comprehensibility. Means algorithm can be understood. It should be in such a way that it can be understood easily with the help of human efficiency. So like high level of correctness, high level of efficiency, high level of comprehensibility, these three characteristics makes an algorithm a good one. And we have like lots of algorithms. So all the algorithms broadly they can be put under subsets. Okay, under subsets. So like so there is a relationship we can see here, we can see here there is a relationship between all algorithms, AI, artificial intelligence algorithm, and the machine learning algorithm. So this figure actually it tells that mainly we have in all the algorithms we have AI algorithms and ML algorithms. So I have considered one example here. So So this is the example which illustrates AI algorithm, artificial intelligence algorithm, and artificial intelligence algorithm, and a machine learning algorithm. So this I have given the courtesy here, reference to. So here, like, say we have one location and we have to go to some another location. So like most of the people, our dear participants, teachers, so sometime like when we are driving our car, or sometime in while walking also, sometime we put on our Google Map in order to find the location. So our mobile, it gives the direction. So this Google, so Google direction is an example, is an AI optimization algorithm. So AI means artificial intelligence, the algorithm which has some intelligence. Like in foreign countries, we find that there is a driverless train. Okay, so in that their person is not there, so they have some intelligence. So this Google directions is an artificial intelligence AI optimization algorithm. So this Google direction, Google Map, it uses the artificial intelligence algorithm. It explores many route options and returns to the best few. So like as it has the intelligence, so it will, like from this point to this point, there may be different routes. So it explores various route options, and then it at the end it gives the best one. Okay, because it has intelligence. So this is the example of a algorithm which has the intelligence. So we say that Google directions is an AI optimization algorithm. Okay, similarly, like when someone select and modify a route, so this becomes a human computer interaction. So like human can interact with the computer, so that we can change the route. So for example here, like if we see, so this is the best route given by the Google direction. Okay, by the Google Map. So this is the best route we can see from this point to that point. Now in human interface, what happened in human interface, say one person, dog. Okay, dog. So he has changed the route. Okay, from the starting point is same, and what we find that he has put it down here, and then he has reached here. Okay, so this type of an example is known as human computer interaction. So this is also an algorithm, but and actually following a single route is a non-AI. So this person actually he has modified the route with the help of human computer interaction, and he finds only a single route from source to the destination. Okay, so this is an example of a non artificial intelligence algorithm, because it's a deterministic. It has determined that we have to follow only this path, there should not be other option. So it's a non AI algorithm. So whether it's a non AI or it's a AI. Okay, so this all comes under the superset of all algorithms. Similarly, like we have a machine learning algorithm. So in fact, if a person more often than not chooses routes that swing close to the state, or to the places, then it becomes our machine learning. So like machine learning, then non AI, and then AI. So it's like machine learning, we can say that okay, this is somewhat basic algorithm, okay, which tries to find some pattern in order to give the classification, or in order to find the problem. And then we have a non AI, where human computer interaction may also be possible. And at the end, the most advanced one is our AI exploration, or the algorithm which are based on the intelligence, where it gets lots of options, and then it goes to it selects the best one in order to solve that problem. Okay, and then one of the important problem is debugging. So actually, as the word is debugging, so there is a term bug. Okay, bug means it's a problem, it's a kind of insect. Okay, so when in these algorithms, if some problems comes, then we say that a bug has came in our algorithm. So it's an undesirable, exactly we cannot say undesirable, but generally we try to remove that bug in order that our algorithm works properly. And this process of removing the bug is known as debugging. Okay, this is known as debugging. So it's an important term. This debugging is an important term, comes related to our algorithm. So actually, like, problems in algorithms are called bugs. Okay, so whatever the problem, different kinds of problems are there, but problems encountered in algorithms are known as bugs. Okay, looking for problems and fixing them is called debugging. Okay, so debugging is a problem of is a process. Debugging is a step, or it's a process which looks for the problem and fixes out the problem in the algorithm so that our algorithm runs well. Okay, and when we teach our kids, then we will say it's a debugging. So we will break it into so that they can clearly pronounce. Okay, so debugging, it refers to looking for the problem and fixing them in the algorithm so that our algorithm works. And for the kid, we will say just you repeat it. D means like when we say deceleration. Okay, so it's just opposite of acceleration. Okay, decrease. Okay, so D means we are reducing it, we are removing it. And bug, and GING means it's a process, it's going on. Okay, so kid will be very happy to read it. Debugging. Okay, so finding bugs and squeezing them out. So it's a real-time problem, but it's very similar for our computers and for computing also. So all these day-to-day life has been mimicred in our computers. As we are the humans, so we have evolved long back, and computers are not very old as we are. So the main goal of these computers are to mimicry our day-to-day things. Okay, that's why all our whatever the things we see in our common places in our day-to life, these have the very similarity to that of the computers. In fact, the main goal of this computer is to mimicry the human behavior, human system, because our brain is very evolved. Okay, it is very evolved, and the main aim of this artificial intelligence or these computers is to just to copy our way of doing the problems. When bugs are removed, programs work correctly. So we came across debugging here. And now, as our discussion is mainly for as we have dear participants are teachers here, so we will be moving to CS Pathshala now. So actually this CS Pathshala is an association for computing machinery India, ACM India, and it's an initiative to bring a modern computing curriculum to Indian schools. So many countries have already adopted. India has also adopted. So let me give some. What is the mission of this CS Pathshala, and what are the main highlights? Just let me share with you. So the mission of this CS Pathshala is to prepare our students to participate creatively in this digital age. CS Pathshala proposes an activity-based unplugged computational thinking curriculum for primary and secondary schools. And these are the highlights, like computational thinking curriculum. Basically, it's teaching computing without computers. It should not be kept in mind that we are talking of computational thinking, so there must be a computer requirement of computer and this thing. So it's not like this. Computational thinking curriculum, which has been introduced to the primary and secondary schools of our country, and many other countries have already adopted. So basically it aims uh, teaching computing, teaching mathematics, algorithms, puzzles, and all those things without using computers. And this CS Patsala, this has created a mm, community of more than thousands of peoples, and this community created teaching aids which contains 200 lessons, and this is provided at free of course to the schools. It's free, and those community where more than 1,000 teachers are there, developers are there. They have also translated these materials into different languages like Gujarati, Hindi, and Marathi. 30,000 schools in Tamil Nadu learning computational thinking as a part of their math curriculum. So in India, these things have been already started, and those teachers who have been uh, dedicated towards teaching to the school kids. So let us see what their opinion. So I have put here two opinions, and it is, they mention that what teachers are saying for this CS Patsala. So one of teacher, Mrs. Bhalwankar, okay, she is from Millennium National School. So in her feedback, she has given that this session was one of the best sessions because kids came out with very good examples of algorithm in day-to-day life. Could do with some more examples to explain to the students. So like, as I told, as we discussed that algorithm, which is a step-by-step instruction to solve a problem. And in our daily life, we have lots of algorithms, starting from like brushing our tooth to going to the school and again coming back to the home. So at every time we have the algorithms. Then another example of MS Neha Joshi, she is a teacher in Kalmadi School, Pune. So she has told that real life examples and worksheets make difficult concepts easy for children, especially for those who have a fear of maths. Find the same concepts easy to comprehend. So like, as we discussed this, that this computational thinking, basically it is mainly to solve a bigger problem by decomposing it into a smaller problems which are very manageable. So this kind of introduction, or this kind of computational thinking algorithms, so introducing this kind of concepts, this kind of tool in our primary and secondary schools, in our curriculum, helps our students to learn the things in much real way, in much easier way, because most of the things which are for the computers, or which are for the maths, or for any other subjects, this is somewhere it is related with the day-to-day activities, so it makes the things simple. So those students who have a fear of maths, they can find the things easier when we try to make the students learn using the concepts given in the computational thinking curriculum, or through the teaching aids provided in the CS Patsala. So moving next, in this context, I have collected some of the materials from CS Patsala. So as I have put here, but the same we can directly go to the site, and then we can download, and we can see. So that also I will show. But let us see this first algorithm. So this is mainly designed for the students, for school students of standard 1 and 2. So this is the first algorithm, first material for the school student. So it's a very basic, but let's see how interesting it is, and how interesting it will be for our students. those who are the kids, those who are in the 1, 2, or in 4th standard in our school. So this I have taken from the CS Pathshala, bringing computational thinking to the schools. So this is the new concept. It has been introduced now. Okay, it is already inbuilt in our human brain, but now formally it has been introduced. So let us see one session that is devoted on introduction to the algorithms. So for students, like as you are teachers, so I cannot tell you, because you are already been teaching and you have lots of experience, but just I wanted to tell that when we go to the students, so like we teachers, we have that higher level and we may understand, but for them we have to be like them, so that they can understand, and we have to lift them up. So like when somebody in the class, as our audience is kids, it's a say 5-year or 6-year 7-year students, and for that if we would like to introduce algorithm, computational things, programs, so they may fear, they may develop some fear. But as we found that these algorithms are not very tough, but we come across thousands of algorithms in our daily life, so we have to make them familiar with the day-to-day examples, so that even the tough things becomes easier. So this is the main goal of introducing computational thinking in our school to our kids. So how we are going to tell our students, if we are going to give introduction to the algorithm to our class say 2 students. So we will say that, okay, hello class, and now we are going to learn about the algorithm. So let us see a new word, algorithms, because they know about the word. They know this is A for apple, B for boy. So they know what is the word. So now we can start that. Okay, let us have a new word today, and that is algorithm. Okay, then okay, algorithm. Then say apple. So what is an apple? So it's a fruit. So similarly, when we will say we are going to see a new word that is called algorithm. So automatically they will be excited to know what is an algorithm and what are the algorithms in our daily activities. And then the process will start. So let's have some fun word. And this is for the students actually, those who are in class 2 standard. So let us have some word fun. So as the kids, they already know different single words, like this is a goat, this is a globe. Okay, so this is a hospital ring. Okay, so they already know. So we may ask the students, though whatever the algorithms we discussed before this CS Pathshala in our previous in our few minutes back. So we have started with the algorithm, characteristics of algorithm, what are the characteristics that makes algorithm good, what is computational thinking, all those. But those things, the same things now, it will be introduced to the student with the aid of computational thinking in a very easier way. We will try to relate a new thing with the already previous things which the students know a bit. Okay, so this is also known as like mental hook. So a new word can easily be remembered if we can mentally hook the new word with our previously known words. Okay, and this is the concept of computational thinking. And here with this example, they have tried to do this. So before we learn a new word, let's look at these pictures below. So actually, like teacher wanted to introduce algorithm. Okay, but so first, algorithm is a word for a kid. He doesn't know anything about algorithm, but it's a new word. So before we learn a new word, let's look at this picture. So they show some pictures to the students, because these pictures are somewhat students are familiar with these pictures. So can you think of one word to describe each of these pictures? So it may happen that the class will be silent for some time, but just request some students that you stand up and just tell what is this. So similarly, so definitely some student will try to find the pattern. Okay, this pattern is somewhat similar to goat. So even if it is a big goat or small goat, based on the pattern, because human, this computational thinking, or the human, the way he thinks, first thing comes the pattern. So patterns are very easily recognized by the kids. So they will say that, okay, say it's goat, or let us try to help them to say that this is a goat, this is a globe. Okay, like this, they will try to find those things. So otherwise we will give some words to them. Okay, like we will ask the students, we can see here, like, though we are trying to introduce them a new word algorithm, but how we have started with the, we have we have we have broke that problem into different things. We have started from this concept. You see how well this material is designed by CS Patsala in order to introduce the word algorithm. So we will plot some words here, and we will tell the students to just match it. Okay, so like hospital, goat, ring, earth, and mom. And then we will give 5 words and 5 pictures randomly. Then definitely they will match it, that okay, this is the hospital, this is god, this is ring. Okay, they will match it. And then after matching this, like, say this is god, okay, this is ring, like this, students will match it, they will find it interesting. Okay, because they know it, and there is a picture. Okay, and then from hospital we will take first 2 words, and from the god we will take first 2. Okay, similarly, first 2 letters from the ring, last 2 letters of earth, and the last letter of mom. So like this, we will combine it. Okay, we will combine it. So here we find ALGORITH and M. So the new word is algorithm, and then students should be encouraged to speak it loudly and many times. So they will say algorithm, algorithm. So not the new word has been introduced to them. So what is an algorithm? So an algorithm is a list of steps. If you follow these steps, you can finish a task. So we will tell the students that algorithm is a list of steps, because what we did, like, if we recall, we tried to combine all these selected letters from different words. Okay, so what is an algorithm? So for a student, we will say that an algorithm is a list of steps, and if you follow these steps, you can finish a task. Then the students will get happy. Okay, if we follow these steps, then things becomes completed, the things will get completed. An algorithm or the list of steps helps us to complete a task properly. So in this way, algorithms can be uh, made understand by the students. Then use algorithms for the task. Here are some tasks that can be completed using algorithms. So these are the examples of the algorithms, like climbing up from one floor to the another, getting ready for the school, make a paper plan, select your favorite toy in a shop. So this is also a problem. Okay, so selecting a problem. Okay, selecting a problem. So say select your favorite toy in the shop. Now select the biggest number among a list of numbers. Okay, buy and eat a mango. So these are, though it looks very simple, but it is very very closer to the complex algorithm. It's programming, the way machines handles. So these are very, though it seems very simple, but it helps to relate with a very complex algorithm. That's why students should be taught with the day-to-day examples. Then, like, climbing up the task. So can you tell how do you reach from one floor to the another? So so actually our respected teachers will ask our students that, okay, you tell, like, say climbing up the steps, this is an example of our day-to-day algorithm. So what should be the steps? Okay, so we will now use we will use an algorithm to climb up from one floor to the another. So first one is that first step of this algorithm for climbing up the steps is to start walking. So the first step is to start walking. You cannot reach anywhere if you do not begin somewhere. It's very true. So first of all, start walking and reach the first step. So start walking and we will reach to the first step. So once the first step is over, then we will move to the second step. Okay, now begin climbing. Go from the first step to the second. Then once we reach to the second, then we will see whether the third floor is there or not, third step is there or not. So if it is there, we will move it to that. And then we will move from second to third and from fourth. And at the end, we will reach to the top. Keep moving until you reach to the last step. Step 5 in this case. So in this case, step 5. Okay. And when we reach to the step 5, we have successfully climbed the steps and reached the next floor, and the task is completed. So climbing up the steps is an example of an algorithm. And what are the steps required for climbing the step? So these steps are these steps. So this set of steps in this example, the set of these 5 steps, starting from start walking and reach to the first step, then move to the second. So from first to fifth steps, this set of steps are known as algorithm, and these algorithms helps to complete the task. Okay, so this is about the algorithm. So in this way, students of class 2 level or 1 level will also understand. Similar is the example for for like for preparing a tea or a coffee. So algorithm means like, so it's now clear. So it's a detailed step-by-step instruction or method for solving a problem or completing a task. So now we know very well what is an algorithm. So algorithm, it's a detailed step-by-step instruction or method for solving a problem or completing a task. And this is an example of an algorithm which gives the sequence of steps to prepare the tea. So first, like, heat up or boil the water. Then the next step is place 1 tea bag in a cup, add freshly boiled water to the tea bag, wait for 5 minutes, remove the bag and enjoy your tea. So these are the steps, sequence of steps to prepare to prepare a cup of tea. But one thing, that it's not that we must that only one algorithm is there. There may be some different way to complete the task. So algorithm may not be unique. We may have different approaches to solve a problem. So all these approaches will be known as algorithm, different algorithm. Similarly, we have, like, for students, like, what is the algorithm to get ready for the school? Okay, so these are the day-to-day things. But now the same things, this will be, once we understand it logically, step by step algorithm, so computational things comes in our brain, and then these we will try to make in such a way that the system or the computer or mobile understand, and in that way this can be transferred to the machine learning, so that these things will work automatically. Okay, so like this is also an example. It's an algorithm to make a sandwich. Okay, so these are very day-to-day examples. So okay, so just in order to recap for the students, at the end we will say that, okay, so today in this session uh, we become familiar with the new word algorithm, and we saw that algorithm is a step-by-step procedure to complete a task, and algorithms helps us to complete some daily tasks. Okay, for example, like climbing from one floor to the another, getting ready for the school, making of a sandwich, making of a tea. So these all are the examples of day-to-day life algorithms. Now, algorithms and computers. So algorithms are the basic building blocks of computer programs. These are as important to programming as recipes are to the cooking. If we have list of steps in form of an algorithm to complete the task, then computer can do the task for us. Okay, so the main motive is that, like, as we know that the algorithm is a step by step instructions. So we have to, so any task, any problem, any complex problem we will take and we will try to develop the algorithm so that these algorithms can be easily understood by the computers. So if this can be done, then the computers can do all the jobs for us. Okay, for example, like in many countries, like there are like automated robots are there, so they are doing work for the human being. There are driverless cars, driverless trains already they have been operated. So a lot of things have been done. So now, so this was one session. We move to the second session, say, where we will be knowing about the loops. So if I say iterations, loops, bugs, these all tough words, so class 2 students may not be aware of that. So the main goal of this computational thinking, or bringing this computational thinking to the school, is that we will try to make them understand all the computer things also by using our day-to-day life, or how our brain thinks, and how our brain solves that problem. So that we will try to put that into the computers, and how it will be possible. So it will be possible only when we can make day-to-day life, if we connect our day-to-day activities, day-to-day algorithms, the things which are happening to we have to basically map that from our day-to-day to in such a way that our computer understands that. So here we are going to discuss about the loops. So in the previous, like, we saw algorithms, loops. So algorithm tells us how to do a thing that we want to do, such as tie shoelaces, make a paper ball. Because this algorithm, it gives a set of instructions to follow, and if we follow the set of instruction given in an algorithm, we will be able to solve the problem. So algorithm can also help us to solve the problem, such as how to find the shortest way to the school canteen, how to share sweets among friends. So algorithm is a list of simple steps. If we follow these steps one after another, we can complete a task, or we can solve a problem. So algorithm means detailed step-by-step instructions or method for solving a problem or completing a task. So these algorithms we saw. These we saw these things. Okay, so making paper plans. Okay, so how to make many paper plans. Now, so here they would like to introduce a new concept of loop. Okay, concept of loop. So actually, like, so it will come here, like, to make 6 paper planes, the algorithm is saying the same thing again and again. So suppose if we repeat the things many times, so that is not very convenient way. Okay, so it's not a good way or a better way to solve a problem. For example, like, if you have to make 6 paper planes of different colors, what will be the algorithm? So use the same algorithm to make a paper plane and use red paper. Next, use the same algorithm to make a blue paper plane. So basically, actually, what they are saying, that suppose for this, suppose they are writing here, what is happening here, we tried here, the problem is to make a paper plane. Okay, paper planes we have to make, paper planes. So they have given the 5 steps. Okay, they have given the 5 steps here. So if we go to the previous slides, so this is the plane here. Okay, paper plane, aeroplane. Okay, paper airplane. Okay, this one. So say this is the algorithm. Say first step is fold paper in half long ways, then fold in the corners like it is folded here, fold bell corners into the corner. So this pictorial representation is very clearly depicts how to make a paper uh, airplane. Okay, so now this algorithm is there. So now suppose if I say that, okay, this is the, say these are the steps to make a paper plane, or plane means airplane. Okay, airplane, paper airplane. So now if I say that, okay, now say we have 6 different colors, then you please give the algorithm. So is it good way to write this 6 times and just for 6 different colors? So for that actually these loops, iterations, these things come into picture. Okay, so let us see here. So for 6 different colors they have written 6 times here, you see. So it's not a good way to write the algorithm. Okay, so algorithm, as the steps remain same, only the color of paper changes. So there we can make loop that, okay, just if means it doesn't matter actually what the color is, but steps remain same to make the airplane, paper airplane. That's why it is saying that can we do it in an easier or better way? So why to write this 6 times, all these steps 6 times for 6 different colors, where the task is the same, that we have to make a airplane, we have to make a airplane. Similarly, like say let's say we love to hear a song. How will we tell our friend to sing it 4 times? So is it that, is it good to say 4 times, friend sing my favorite song, friend sing my favorite song 4 times? No, we will say, so better way of the algorithm, or better way to instruct or to request them, is to say, friend sing my favorite songs 4 times. So 4 times. So this introduces the concept of loops, that okay, first the song starts and it ends, then once it ends, again you start and let it end. So how many times you have to do this? You have to do 4 times. So when you request someone that, okay, you please sing my favorite song for 4 times, in that time, this 4 times, as it is in our day-to-day life we are saying, but actually we are introducing loops in terms of the computer language. Okay, similarly like repeat. Okay, repeat. So repeat, loop, iteration, so these all natural day-to-day activities, we always use it, and the same we have to relate with the algorithms or the computers or the programs which computer can understand. So they have designed this material in such a way that the students can easily understand. So new word is loop. So doing the same thing again and again is called loop. So not, there is no need to tell 10 times. If you want a people to sing your favorite song 10 times, just you request or just tell that, okay, please sing my song for 10 times. So this 10 times, so this is basically a loop. Okay, so the action of doing something over and over again is known as loop. Okay, so replay of songs, climbing more than one floor, repeat climbing one floor, algorithm more than once, algorithm to eat 5 mangoes, repeat or loop the algorithm to eat 1 mango 5 times. Dance, repeat the dance step by clap, kick side to side, jump and swing arms. Okay, so these are the examples of loop. So this is the loop activity. Okay, loop activity. So as I have to see the timing also, so timing of my talk, which has given. So this is the example of a loop where repetition, when the things starts and it ends and again it repeats. So this is the examples of the loop. Okay, so like this like sun rises every morning, goes over our head at noon, and then sets in the evening, and the next day, and the day after that loop goes on and on. So there is a repetition. So it's the concept of loop. Okay, so what we learned in this session for our students, so basically some algorithms, examples of algorithm, new word loop, where loops help us to do tasks that need repeating the same steps many times. For example, like singing of a song for 10 times. Okay, so no need to tell 10 times, but just say that please sing a song for 10 times. Okay, no need to repeat it 10 times. Okay, so now third, I have uh, like I have also I have taken this example. So very just I will show the slides, just like get ready for the school picnic. So this is an example of algorithm. So how to go to the school? So actually we have to follow some how to go for a school picnic. So we must have some steps. Okay, so these set of steps is known as algorithm. Okay, so how to ready for school picnic? So uh, like uh, we have to wear clothes, wear shoes, comb our hair, wear cap, pick up our lunch box with the ship. So there are some steps. So these steps are the algorithm for getting ready for the school picnic. Similarly, like we have lots of steps like crossing the road car. So what should be the algorithm to cross the road? Okay, so we have to wait for the traffic light to become green, then look right and wait for the cars to step. Everything is fine, then we will move. So these steps are the algorithm to cross the road. So we have like many examples, and we must have the different methods to get a problem done. So algorithm cannot be necessarily that it should be only one. We may have a different algorithms to solve a particular problem. Okay, and how we decide which algorithm is good? So based on the application. Okay, based on the application, like suppose if I want to go to the hospital. So if I am a bit fine, if I can go with my bike, I will go, but if it is rainy, then I have to take car. So in these two algorithms are different, but the problem but we have only one solution, only one aim, that we should go to the hospital. So if it's raining, I will not prefer bike, I will prefer taxi. But if it is the day is fine and I am good, I can go with my bike. So here there are two approaches to go to the hospital. So we have two different algorithms, and how to decide? So we have to consider some conditions where the output becomes uh, becomes easily, and it should be achieved with the minimum effort. Okay, and the repeating the same step is called loop. Okay, so loop algorithm we find. So make algorithms for your own. So take any problem, say we say these are the pandemic days. So we have a plan that okay, we will have tour after this pandemic is over. So just check out a program. So write a program, a list of instruction that how we are going uh, to go for a tour. So make algorithms of your own. Choose some big problem, and then what should be the steps? So that step, when we write systematically, this list of steps becomes the algorithm. And then sorting problem, like how to sort it. Okay, like suppose which room is better? Definitely this room is better. This Definitely this room is better. Okay, this room is better because it is very well organized. Very easily we can sort it out. Like all the books are in one place, computer is here. Okay, but here in this image, like everything is random here. Everything is random. So it becomes very difficult to sort out. So sorting in computer science, arranging an order sequence is called sorting. Okay, so this example, like how does a computer sort numbers in ascending order? Okay, so like then there is a iteration. Say a robot is there or a computer is there, and we say that you arrange it in ascending order, like from 1, 2, 3, and at the end 5 should be there. So first it will take any number and it will compare these two. So what? So it will compare these two, and it will keep the lowest one in the left side. Okay, so like this it will compare 1 and 5. It will compare. If 1 is greater than 5, if yes, then swap the card positions. So likewise, it will just compare these two, and at the end, and all the things will be sorted out. But it will take 25 steps because there are 5 numbers. Okay, so it will have like 25 iterations. Okay, then like bubble sort is also there, which will be of like which is another way of getting the number sorted. So if we have 5 numbers, then maximum time taken for sorting the list will be 25 iterations. Okay. So before summary, okay, before summary, I will just like to show this CS part Sala. Okay, so in Google, like in